Let's look at another example. Let's look at 44. We have f of x is equal to x ln of x minus x, and we want to analyze that first derivative. So taking the first derivative, we're going to have to use the product rule. Product rule says it's the first times the derivative of the second plus the second times the derivative of the first. And then taking the derivative of the last term, we're going to get minus 1. So our derivative is 1 plus the ln of x minus 1, which simplifies to the ln of x. So now we want to take this derivative and set it equal to 0. So we can rewrite this as an exponential function. So let's recall that when we have a log and a base, x is equal to the exponent. In this case, the base is e, the exponent would be 0, and that's going to be equal to x. And we know e to the 0 is equal to 1. So there's our critical number. Now, we also have to keep in mind the domain for this problem. Because we have that ln of x here, the domain has to be greater than 0. So when we create our sign chart for that first derivative test, it can't go below 0. We can't plug negatives in here. And we do have 1 as our critical value, so it's going to go on the sign chart. And now we have two different pieces we're going to simplify and test. So let's plug in something between 0 and 1, like 1/2. And I'm going to substitute that into that first derivative. So f prime of 1/2 is going to be the ln of 1/2, and that's going to be a negative value. So we're going to be decreasing on that piece. Now if we substitute something in bigger than 1, like 2, we're going to take the ln of 2, and that's going to end up being a positive number. And all we care about is the sign, if it's positive or negative, because that tells us the slope is increasing or decreasing. So here's what we know. Based on this sign chart, f of x is going to be decreasing on that first interval from 0 to 1. And then it's going to be increasing from 1 to infinity. We do have a change that's happening at 1. We're decreasing, then we're increasing, which means we have to have a minimum at x equals 1. So let's find that y-coordinate. To find the y-coordinate, we are going to substitute 1 into the original function. So remember, the original function was x ln of x minus x. So we're going to have 1 ln of 1 minus 1. The ln of 1 is 0. So we're going to get a negative 1 out for that y-coordinate. So the point where we're having a minimum is at 1, negative 1. Let's do one more, and let's do 46. So this time we are analyzing the function f of x is equal to x squared minus 9 raised to the 2/3 power. Okay, so notice this one's not going to have a domain restriction. This is the same thing as taking the cube root of x squared minus 9 quantity squared. And we know when we take the cube root of something, we don't have any domain restrictions. Also notice whenever we look at that radicand, which is the stuff under the radical, it's always going to be positive because I'm taking a number and I'm squaring it. So I'm going to end up taking the cube root of something that's always positive. So let's start our process. We first have to take the derivative here. So this is going to require a u substitution, and I'm going to do that over to the side. u is going to be x squared minus 9. du is going to be 2x, 2x. When we do our rewrite, we're going to have u to the 2/3, and the derivative of u to the 2/3 is 2/3 u to the negative 1/3 times du. So when we make our substitution, it's going to look like this. And I'm just going to clean that up a little bit. We're going to have 4x in the top, and then we're going to have 3 times x squared minus 9 to the 1/3 in the denominator. So there is our derivative. So let's talk about where are we increasing and decreasing? How do we find those critical numbers? So to find critical numbers, you set the derivative equal to 0. And in this case, we can multiply both sides by that denominator. So we would get 4x equals 0, which means x is equal to 0. But we also have to consider, where is f prime of x undefined? Well, this is going to be undefined anywhere that denominator is equal to 0. So let's look at where that denominator is equal to 0. We could divide both sides by 3. We could cube both sides. Move the 9 over, take the square root, and there are 2 places where that denominator is equal to 0. So those numbers have to go on the sign chart also. So here's our sign chart. We know there's no domain restrictions, so this side goes to negative infinity and this side goes to infinity. But 0 was a critical number, and then we had 2 places the derivative was undefined. So now we're going to start plugging things into that derivative. So I'm just going to rewrite the derivative over here so we can see it, and I don't have to keep moving up and down on my screen. So let's plug in something in this interval. I'm going to use a -4. So we're going to have -16 over 3 times -4 squared is a positive 16. So we have 16 minus 9 to the 1/3. So we have a negative in the top, and the bottom ends up being positive, so this ends up being a negative value. Now let's pick something between a -3 and 0. I'm going to substitute in a -1. So we're going to have 4 times a -1, which is a -4, over 3 times -1 squared is a 1 minus 9 to the 1/3. So the top's negative. The bottom is going to be, this is going to be -8 to the 1/3, which is a negative. And we have a positive times a negative in the bottom. This is going to end up giving us a positive value. So now, picking something in this next interval, I'm going to use a 1. And this is going into the derivative there. 4 times 1 is 4 over 3 times 1 squared, which is 1 minus 9 to the 1/3. So we have a positive over a positive times a negative. And that's going to give me a negative. And then let's pick something here, like 4. So 4 times 4 is 16 over 3 times 16 squared, 4 squared, which is 16, minus 9 to the 1/3. So I have a positive over a positive, which is going to be a positive. So from that sign chart, we can tell where we are increasing and decreasing. F of x is increasing on those two intervals, -3 to 0 and then 3 to infinity. We are decreasing from -infinity to -3 and then from 0 to 3. Now let's talk about where we have minimums and maximums. So if we look at that first number, -3, we are decreasing, then we're increasing. That means we have a minimum at x equals -3. Then we're increasing to decreasing. That means that's going to be a maximum at 0. And then we're decreasing and increasing, which means we have another minimum at 3. So now that we know where that's happening, let's find those y coordinates. So our function was f of x is equal to x squared minus 9 to the 2/3. That's what we're going to use to find those y coordinates. So if we substitute in a -3, we're going to have -3 squared, which is 9, minus 9 to the 2/3. That's going to be a 0. So our point is going to be -3, 0. And then we're going to do the same thing for that 3. Substituting 3 in is also going to give us 0. And then when we substitute in 0, we're going to have 0 minus 9 raised to the 2/3. And that's the same thing as taking the cube root of -9 squared, which is the cube root of 81. So it's not a nice number, but it is a number. So there's our point for that maximum.